We have a session for you about what we've learned reverse engineering the app stores. So hopefully this got you in the room, and now we just have to convince you it's interesting. Before we do so, we have the usual slides on our company, AppTweak. If you're not familiar with us, we are an ASO tool working to help apps and games get powerful insights in easy interface with data science. So we work with many names, basically bragging rights all over here. We're up until tonight, at least, best ASO company, and obviously we're going to win again tonight. So please keep your fingers crossed for us. And overall, we really love working across different verticals, across different countries as well. Up to the point where we actually wrote a book. We co-wrote a book with Feature. Not sure if they're in the room, but shout out Feature. Hey. We co-wrote a book with Feature on App Store optimization. It's 600 pages long. It looks massive. You can find it at our booth. So feel free to look at the object. We're very proud. Now, who are these people talking to you right now? This is Jonathan.
Hello,
My
nice
name
to
is
meet
Simon. Jonathan is our head of data science, so he basically powers the work that I do, and he's actually doing the heavy lifting. So today he'll explain to you what he built with his team and how cool it is. As head of ASO, my role is to help some of our clients with consulting services and overall advice on what goes on in the world of ASO. We're hiring with AppTweak in multiple countries in the world, but most importantly, being a Belgian company, we love chocolate. So I promised we would talk about how we reverse engineer the source. So we're going to, in the first part, lift the hood and show you how we built a tool called Atlas that really helped us map the stores and understand how the App Store and the Play Store process things. Then we'll go into some examples that we've confirmed or discovered with Atlas, how we build features around it, and what lessons we've learned and how you can apply them to your marketing. And there'll be a short conclusion about what's next, because there's a lot more than that we want to do. So starting with the question of building a structural understanding of app stores. Basically, we know that ASO is one of the many tools in a marketer toolkit, and marketers are basically in the app world confronted to a situation where you have an app, which I would say can be summarized as not only a product, but also a brand, and that you try to boil down into a unique selling proposition, which you want to take to customers who are individuals. Here we'll say that they are mostly people with needs and desires. And those needs and desires may or may not transform into intents. So to give you an example of why I say it may or may not happen is because I may be cold, but I may not grab a sweater. But if I'm hungry, I'm definitely going to hit the buffet afterwards. So in the context of the store, our challenge is that there is this ideal situation where we just want to have the match directly from product to app. But we have these marketplaces. They're definitely middlemen in the funnel, and they actually create rules, which are that you're going to need to turn your USP, turn your product and your brand into metadata. And users are going to go from their intent in finding something to either searching, browsing the store, sometimes coming from an ad, but that's going to be a lot of behaviors that lead to potentially an install, an update, or actually leaving the product page. So there's multiple options here. And our challenge is to understand how can we meet the right customers, find a match between the right customers and the right app in the context of the store where you have this additional hurdle. And so that's where we started the notion of, is there anything we can understand for how the store processes metadata, how the store processes behaviors? And that's where we said, well, actually, we know the results. So how about trying to go backwards and start to figure out how we can, from the search results, for instance, start reverse engineering. We know what metadata are available, and how does this match behaviors, and as a result, what is the logic behind an algorithm in the store?
Yes, exactly. So as Simon said, those stores have their own algorithms, and our project was really to understand the logic behind the algorithms. And then a good starting point is just to look at the data. So basically, since 2014, at AppTweak, we're collecting the data on which apps ranks on which keywords for like over, I think, 30 million of keywords, if you take all the languages. And we do that every day. So we end up with a very, very large databases on all, with pairs of application and keywords that like correspond to each other. And we think that using this information would be very helpful to basically understand what's the algorithm behind. So yeah, you can go. So, okay, we can look at all the countries that we follow at AppTweak, but we decided to focus on the largest one. So we took the 66th largest country, like 20 languages, and that corresponds to actually 20 million of keywords that are mapped with 6 million of applications, which is a huge, huge amount of data. It corresponds to like 6 billion pairs of applications and keywords. And of course, we do that both for the App Store and the Google Play Store. So we really focus on that data, really looking at, okay, what are the pairs of application and keywords that the algorithm thinks are valuable, and we want to deep dive into this. So our approach was, as Simon just introduced, was to mimic the algorithm itself. Let's try to reproduce the result that Apple and Google are doing and analyze our own algorithm once we can reproduce theirs. Okay, so that was the starting point. So we used like a bunch of NLP techniques, machine learning models, to reproduce those results. And once we had the results, I mean our own algorithm, we could look at it. So our goal, if you can just switch, Simon. Yes, our goal was to have this kind of Rosetta Stone that we could query to really understand the logic behind the algorithms. But to be honest, like having a Rosetta Stones for those algorithms is huge. It's clearly impossible to understand all the dynamics of the app stores. So even though you might be able to reproduce the results, it's still very hard to understand all the characteristics of the algorithm. And so actually what we did in the end, we ended up with a map where we decided to position all the apps and all the keywords on one single map per store, so that we could like look at the position of the apps and the keywords together and see how close they are to each other, how semantically similar they are to each other. So we have this gigantic map. It took us like 2 years to to have it, but this is just a subtract of the data. And it's like a gigantic map with all the keywords and all the applications. I mean, the 20 million keywords and the 6 million applications we use for the project, even though we can add more. In green, you have all the keywords. In red, you have the applications. I just took a subtract. And what you can see is that they actually have like some kind of clustering already on that picture. Here's something is happening here, nothing is happening there. And we can go deep dive into this data just to really understand the logic behind the App Store. The main idea behind this map is that if you take two keywords that are semantically similar, they would be very close to each other. And if you take two apps that are semantically similar as well, that are having the same product in the end, they will be close to each other. And the last thing is that keywords and applications are comparable on this map. That means that the keyword of a brand is very close to the position of the application itself. Okay? So we have built those two gigantic maps, one for the Apple App Store, one for the Google Play Store, that really capture the notion of similarity within the algorithms of Apple and Google. And we want just to look at this map, extract the information directly from the map to really capture the inner knowledge of the algorithm. Even though, of course, we don't have access to the algorithm, we capture the inner meaning of the entities within them. So this is Atlas. That's the product we built. Atlas then it's a mapping of all the apps and all the keywords according to their semantic meaning. As I said, it ensures that the keywords that are positioned close actually mean the same thing. It also ensures that similar apps are positioned close to each other, and apps and keywords are comparable. And this is a very big thing, that you can always compare the similarity between an app and a keyword, but also an app, and also a keyword and a keyword. Yes. But then, okay, we have this map, and the first thing we want to do is to basically look at it and look at some data. So First thing I did, I just extracted the top charts, the 500 top charts in the whole category. So that's basically the 500 most famous apps at the moment in the United States on iOS. I asked for their position to Atlas. I mapped them and just colored all apps per their main category. Okay. The first thing we can see is that actually what Atlas captures is already this notion of category. Atlas has never heard about categories. Atlas doesn't know what a category is. He never receives any kind of information related to the category. But still, when it positions application according to the product, according to the semantic meaning, we see that, for example, this is a cluster with all the food and drinks application, and this is a cluster with all the shopping applications. And we can go a bit deeper, like this cluster here. These are only VPN's applications. So Atlas captured this notion that there are VPN's application on the stores. It doesn't know what VPN is, but there is a specific niche semantic for VPN apps. It's not really related to other things, so we try to find a position where that is a bit remote from the rest of the of the apps, but still it could identify all the VPN apps and put them together in one location. Okay, and a cool first learning is that actually VPN apps are made of both utility. I mean, they either classify in the utilities category or in the productivity category, depending on your marketing strategy. And if you look at the cluster itself, you will see one outlier. This app here, which is Shadowlink, it ranks in the business category. And it's the only one in the business category that is a VPN. So actually, we don't know yet if it's more like a marketing strategy or if it's just a misclassification. We could deep dive in the metadata of Shadowlink just to try to understand this. But just by looking at Atlas in 1 second, you can see, oh, something real is happening here. Let's have a look. Another example is this cluster of app here. In pink, you would have all the sports app. In orange, you have all the entertainment apps. And if you look in the middle, what are those apps in the middle? Then you find apps like Fox Sports, Watch Live, which is basically a mix of entertainment and sports. And Atlas really captured that. It doesn't know what sport is, it doesn't know what entertainment is, but it knows there are those two concepts that are close to each other, a bit overlapping, and the overlap are all those applications that broadcast sports, basically. Okay. Another example, that's the board game category. So I took the 500 apps that rank in the board game categories, plot them with Atlas, and then this is the plot. Each square is an app, a mobile board game, and I ask another algorithm, my own algorithm, to do some clustering. So I just color all apps per their position on the map using some kind of clustering algorithm. And it turns out that those clusterings end up to be very specific applications. Like the green cluster here is made only of chess applications. The yellow cluster here is made of crosswords application. Then you have a Sudoku up there, like coloring game there, mahjong, dominoes, dice games, checkers. And really, Atlas is able to really identify what is your app doing exactly, give it a position according to the rest of the other apps. And if you look at the position between checkers and chess, Atlas was able to say, okay, those are two different things, but yet they're quite close to each other. So let's position them in a way that you can quickly jump from one to another one. Okay. But then Simon, what do you see here?
Well, now that Jonathan basically came to me, showed me this, and asked me what does my crazy marketer's brain see. And so the first thing I said was that when we looked at the VPN case, not only did we see there was two categories that actually represented VPN, but we could see that with this notion of distance, and when there's no distance like with VPN, there's also porosity. That tells us that there are certain categories that are going to be semantically close to each other, sometimes even pouring into one another. But there's also going to be others that are going to be standing very far apart. So that's already something that can help you formulate more strategies around what people expect. If you're thinking about what kind of games maybe or apps may be relevant to people who would find my app, you know that it's going to be the same, and you can invert it when you start thinking about advertising strategies, etc. Another thing we could establish for sure was that your category in itself is at best a medium or weak signal for how the app is going to understand your product. So I have another example here, which was that we looked at the social networking category less than a week ago. And we plotted it against a cluster that we've created that we call a DNA, and that we call for this one social networks and communities. And what's interesting is that if you look at our list, I'm pretty sure you're familiar with all the apps in here. You're not really surprised that they're considered to be social networks and communities. But there's only three of the, in the top 10 of this DNA, there's only 3 apps that are actually in the social networking category. And since our DNA is based on the store itself, it confirms that the store will actually know that if you're looking for a social network, you can look through the categories if you know where to find them, because they've become harder and harder to find. But if you just search for a keyword like that, you're going to end up finding apps that may be scattered across multiple categories. Another thing is the store offers certain stories. So here, this is a story that I found yesterday on my phone, social networking basics. Well, top 3 are actually not in social networking. So this to us is a great way of understanding better what impacts algorithms and what has less weight. Another example was looking at keywords. So Jonathan came with a great idea, which was, let's do cocktails.
Yes, okay. So let's take 3 keywords like lemon, lime, and scooter. For a usual human brain, not a marketer human brain, but for a usual human brain, like a lemon and a lime are basically the same thing, right? You make cocktail out of them, basically. A scooter is something completely different. It's a mean of transportation. I mean, I'm pretty sure your mom will never say, yeah, scooter and lemon are pretty close to each other. It's the same concept, right? Maybe for you it is, but for your mom it might not be. And we really wanted to capture this notion in Atlas that, okay, a lime, in the context of an app store, a lime and a scooter is more or less the same thing, while a lime and a lemon are 2 very different things. And this is actually also captured by Atlas. If you look at the live search on, can you just come back? If you look at the live search on lemon, then you see it's a bunch of apps, very different apps that basically use the keyword lemon as their brand. But if you look at the live search for lime or for scooter, then you find pretty much the same apps, it's scooter rental apps, okay? So we really wanted to be able to capture this notion so that keywords are more than sequences of letters, but also like carry a deeper meaning that can be quantified. And then I just look at the position of those 3 keywords in Atlas, and this is it. So you find that lime and scooter are actually close to each other, while lemon is pretty far away. And that makes total sense. We want Atlas to capture the App Store semantic of the keywords. And you can even look at the apps around those keywords. Can you just go to the next slide? Yes, thank you. You have lime, bird, and spin that are just located next to lime and scooter, but pretty much far away from lemon. So Atlas is able to say, okay, lemon has nothing to do with birds, but scooter is very relevant for the application birds. Okay? And so therefore, I mean, I can look at this specific area and I will mostly find only scooter rental apps and like scooter specific keywords, like rent a scooter, scooters, anything. Yes, Simon, do you want to add something?
Yeah, so this may feel obvious when we look at specific examples, but what this actually tells us is that natural language and store language are not the same thing. So there are these examples that we will anticipate because people in this room, I'm afraid for Jonathan, probably know Lime is a scooter company. But it's going to be something we can do at a larger scale. Another thing is this explains how the store is able to identify typos, how it's able to understand acronyms, and even how it's going to make the difference between the two. So again, being able to do this with any keyword and any app in the store is extremely powerful. But so Lime and Lemon, you probably knew. Do you know what COC stands for? Clash of Clans, of course. Peter, very familiar. Do you know what CIC is? Turning to French people in the room. It's a bank, exactly. There's one letter. If you look at your keyboard, it's next to the O and the I are next to each other. So if you looked at other things, and in here, I have to admit, being French, I looked at other banks, and BNP is a famous one. If you looked for BMP, you would get the same results as for BNP. But between COC and CIC, there's a massive difference in results. This is taken from Google Play. Same logic applies to the App Store. So that is also going to help us understand how keywords are actually linked to one another. And that does mean that when you're going to start thinking about keyword optimization, whether for ASO or ASA, you can start thinking that it's not just about combinations that you immediately identify. It's about you can get more relevant based on other keywords you already target. So in here, what we learned was that store algorithms are already trained to see keywords as more than a string of characters, and that they look at these as objects with meaning and intent based on what user behaviors they find.
And this is captured by Atlas. Yes, one last thing. So again, I said that the distance in Atlas is a measurement of how similar two elements are. Right? So if you take one app and one keyword, the distance is a measurement of how relevant this keyword is for the app. And then again, if you take the same example as before, then you would have like the application name that is positioned there, the keyword scooter that is there. And just by looking at the map here, I can tell that scooter is pretty much relevant for Lime. Again, it's an obvious example, but it generalizes to any pair of app and keywords. If you take lemon, lemon is pretty far from Lime, so lemon is not very relevant for the application name. And this turns out to be a feature in AppTweak where we could really quantify the relevancy of one keyword for an application. So this is the application Strava. Those are a few keywords for the application Strava. And if you focus on run and running, then you see the relevancy scores here, 30, 66. That means that for Strava, the keyword run is not that relevant, while the keyword running is actually pretty much relevant. And that's, for a human brain, that's pretty weird. To us, like run and running are basically the same thing. But then if you look at the live search, yes, thank you. If you look at the live search, you see that the apps that appear on the keyword running are mostly running apps like Runkeeper, Nike Run Club, Strava, Map My Run. And if you look at the keyword run, then you see running games like Subway Surfer or Temple Run. So actually, in the context of an app store, run means a running game, and running means a running app. Okay, this is really quantified by Atlas through the relevancy score that we suggest in AppTweak.
Something that is also interesting as a consequence is that when you look at combinations, you can start understanding which is a dominant word in the combination. And here, that's where I will point here to Run Tracker. Run Tracker, I think if you ask someone in the street, which do you think is the core thing, there would be at least hesitation in terms of which of the two keywords is most important. In here, we see that tracker has to be the important one just because run is not that relevant, but run tracker is suddenly extremely relevant for Strava. And so that means that we're going to start being able to identify new keywords that could be relevant for you. And that's where marketing comes really into place. So first thing, okay, I want to add new keywords in ASO, also in ASA. I'm going to start looking at what are good keywords for my app. If you're doing ASA, you may remember there used to be a time where Apple would even write on their website, your app's relevance to the user's search query, among other factors, meaning the money you spend, determines if your ad is the one shown. Now, with this, you're basically going to be able to start finding low-hanging fruits that will probably not cost too much money and that could bring you installs. You're also going to be able to do sanity checks with keywords that you're already targeting and potentially add negative keywords so that you can remove the sort of bad apples, sorry for the pun, that will cost you money for little return. And then if you become a bit obsessed like me about the question mark of cannibalization. Cannibalization is basically the situation where you're going to bid on your own keyword by fear that someone else is bidding. But it only really makes sense when you bid because someone who's similar to you is actually bidding as well. So if we look at Uber, if Bolt is bidding on them, Uber probably wants to be defending and to pay for search ads on the word Uber. If Komoot is here, I think you guys are in the room. I love your product, but I don't think you're the most relevant. And that's where Uber may say, actually, we don't really need to defend here. And so we're going to look at the relevancy score. We're going also to look at who has the highest share of voice on our own keywords. And we can start building a simple mathematical model where we make hypotheses as to how each app bidding on our keywords are going to convert for the term compared to our own conversion. And that's how you can start coming up with a number, or at least a bracket for how much you're actually spending on brand defense. Because if you trust Apple, probably you spend, I don't know, 20 cents, maybe 40 on defending your brand for each install. But a lot of these installs would get to your app anyway. So the cost you see in Apple in that case is probably not right, and relevancy score is going to help you identify how you can come up with your own number, and even if it's a rough estimate, start making different investment decisions and potentially find other keywords that will cost you less and drive more installs. So these are kind of the lessons we've learned so far. It's only the beginning, I would say. But first thing I want to say, and yes, we are contractually required to show office gifts in every presentation. But the important thing first was to say we should start by validating things that we expect, but that were only hypotheses, because that's how we go from Dwight Schrute just thinking to Dwight Schrute knowing. Another thing is that, as we said, we started by just having this map and started thinking about the most obvious thing you do with a map. However, we know that most of you are thinking, well, can I get a direct itinerary to success? So in the end, we want to start thinking at what is going to be the GPS of ASO, and that's the first stone. So we have already more things coming out with Atlas. We have AppDNA that was just released. Game DNA is coming next. We're going to start running a lot of benchmarks around these, probably try to do more data science. Jonathan is not done with innovation. And we also want to talk to you guys, because you guys also know what you can expect if we're starting to have a map. You're going to have ideas, and that's why we have Marie-Laure, our Chief Product Officer, who's here as well today, and we just want to start a conversation. So we may have time for Q&As, I'm not sure, but definitely come talk to us either now or at the booth or at the event. We'll be walking around as well. Thank you.